Alright guys, this is what the equation is for the general sine function. Now, you can see that there are quite a few variables in this, and the notes actually explain what each one of those variables represents. So if you're looking at, say if you're looking at A, this thing represents the amplitude. So that's almost like saying this is what determines the vertical stretch that's going to be, that you're going to see in a function that you're working with and stuff. Though B represents the period, and again, whenever you're looking at a sine or a cosine function, you always use that equation 2 pi over b, and that's going to give you the period of the function that you're looking at. The C in this case represents the horizontal translation, meaning that you're either going to be shifting the graph to the left, or you're going to be shifting that to the right. And then of course the D represents a vertical translation, meaning that you're either going to be shifting something upwards, or you're going to be shifting that downwards. Alright guys, one thing that you have to realize is that if you look at the notes, they're saying that the period of the general sine function is 2 pi over b. But you can see that in the denominator, this is just lowercase b. In reality, this should actually be 2 pi over the absolute value of b. So keep that in mind. We're going to get to some of the problems where you're going to see why this would be important. So again, this is going to be 2 pi over the absolute value of b, meaning that there might be problems where they can give you something that's going to be negative in front of the x. So what you're going to do is you're not going to put the negative sign in, you're going to take the absolute value of that, which is going to make this part positive. So the period would always come out to a positive value. Alright guys, as an example, we're going to look at these 4 problems. So what do you have to do in this? They're saying you have to find the period of each one of these. Now again, what do you notice about this? You can see that each one of these problems is a sine function. So let's actually start with problem number 1. So you know that this is the original problem that they gave you, y is equal to sine 4x. Now how do you find the period of this? Well, you know that from the equation above, period is equal to 2 pi over, again, remember what I told you, that this is really the absolute value of this, even though in this problem it's not going to be an issue, but you're going to see that once we get to the next problem, you can see that that's negative 4, and if you forget to take the absolute value of that, you're going to end up with a negative answer in that one. But once we get to that, you're going to see that. Alright guys, so what are we going to plug in for the b in this case? Well, you can see that the b represents whatever the coefficient is in front of the x. And you can see that that coefficient in this case happens to be a positive 4. So once you put that in, absolute value of 4 would still be a positive 4. So that's going to give you 2 pi over 4. And at this point you can simplify the 2 and the 4, so you can see that the period is equal to pi over 2 for a problem like this. Alright guys, what about the second problem that you have in this? How would you find the period for that one? Well, in the second problem, you can see that they gave you sine of negative 4x inside of the parentheses, but again, we're going to use that same equation that we used in the previous problem, and we're going to say that the period is equal to 2 pi over the absolute value of b. And how do you do that? Well, again, you can see that the b in this case is a negative 4, but once you take the absolute value of that, it's going to give you a positive 4. So again, this problem simplifies down to 2 pi over 4. And, as you guys saw above, this thing reduces down to pi over 2. And this is what the period is for a problem like this. Alright guys, what about problem number C? Or problem letter C? How would you solve for that one? Y is equal to sine of x over 3. Alright guys, so in this problem, what you're going to see is that the coefficient that's in front of the x is really 1 over 3, and you can see that because you know that there's the imaginary 1 in front of the x. So how do you get the answer in this? Well, again, the equation itself doesn't change, so we're still going to stick with the period is equal to 2 pi over the absolute value of b. It's just that the b in this case is not the 3 and it's not the 1, it's 1 over 3. It's a fraction in this case. So when you plug that in, this is what you're going to get. 2 pi over 1 I always like to write it out like this. And then you got the division sign. Divide this by whatever the b is in this case, which is 1 over 3. Now, you can see that you have two fractions in this, and there's a division sign between the two. So what you can do at this point is that you can apply state change and flip, or take the reciprocal to simplify the answer. And you can see that the period comes out to 2 times 3 times the pi, which would be 6 pi in this case, and that's the answer. Alright guys, how about the last one on this? Okay, so the problem that they're saying is that you have sine of 0.6x. So we're going to plug that into that equation. So let's actually write the same thing out first. Sine of 0.6 x period is equal to 2 pi over the absolute value b, which in this case is a decimal. 2 pi over 0.6. Let's put that in the calculator and see what we get. Alright guys, what do you notice about this problem? Since the b in this case is a decimal, what you can do is, since you want to express the final answer in terms of a fraction, what you can do is you can take that 0.6 and write that as a fraction. And you know that the 0.6 can be written as, we're going to put that thing on the side. 0.6 is the same as saying 6 over 10. So what's really happening is that you've got the 2 pi at the top, and you're dividing that by 6 over 10. So we can say that you got the 2 pi over 1, and then you're dividing this thing by 6 over 10. Now why is this important? Well, now you can actually give them the answer in terms of a fraction, which would be an exact answer, instead of giving them something that would be an approximated decimal. You can also see that 6 over 10 can be simplified by 2 on both sides, and that's going to give you 3 over 5, and then of course the 3 and the 2, well, before you actually multiply that, forgot to flip this thing, so that's going to give you 2 pi over 1 multiply by 5 over 3, and you can see that the 5 and the 2 gets multiplied, so that's going to give you 10 pi over 3, and that would be the period for this problem. Now if you were to put that in the calculator, obviously that's going to give you a decimal, but the thing is, for problems like these, you always want to make sure you give them the answer in terms of a fraction. Alright guys, so that's the end of this problem. We're going to see a couple more examples in the next video.